All right, let's begin with our first company this afternoon. Please welcome Mr. Mike Bishop, CTO from the COGITARI, Incorporated. The topic of demonstration is secure wireless communications with RF monitoring. The company will have 20 minutes to demonstrate their technology, followed by a 10-minute Q&A session. And when you're ready, we'll start the clock.
Okay, let's go ahead. Thank you. Good morning. Again, Mike Bishop, CTO, joined by Jerry Herink, our president. Really appreciate everyone's time already. This entire X-Tech adventure has been very helpful to us. We're very grateful both for the event itself and for your time and attention today. Before I actually power up the system, because we are starting this thing from a cold start, which is basically welcoming every possible gremlin that can show up in the form of Murphy to mess with us, we'll power it up. But before we do, if I could invite you guys to stand up and just look behind here. I'd like to share a few things with you so you can appreciate what's happening, because there are elements of this configuration that are truly unique. There's access points you see here that are inside RF enclosures. So the RF signature of this system is extremely low. We have an access point for a simulated high and a simulated low network. So inside, those are the access points that you would normally want to have the clearest view possible of the outside world to provide, if you want to step around and see that, sir. So you can provide that connectivity. And that's all for the back. And feel free to take a seat now. I was going to spin it around and show it physically, but I think it's easier to have you stand. Thank you for that. So I'm going to go ahead and power it up now. And as this boots, I'm going to have a few minutes of admin things that I need to take care of. But before I hand it over to Jerry to cover a number of unique capabilities of this system, I wanted to reinforce that this is we can take the next slide. Got it. This is a unique system. It's been derived from the first ever Wi-Fi cellular DAS that's actually operating in a SCIF. We can't say where it is, but we have a government sponsor, and there's an operational wireless network running inside an operational SCIF at the TSSCI level. This is technology that's derived directly from that. What we've done is we've begun to ruggedize it, package it for tactical use. The important thing to note here, and the reason it's so significant, is communications are central to our success on the battlefield. If we can't communicate, we can't train the troops. If the troops can't communicate during battle, we obviously can't coordinate any activity. The adversary has the upper hand. Information dominance is key. And so everything really starts with securing networks and making sure that they're as flexible as possible. There's a number of quotes we have from individuals within the PEO C3T. They've been working with the cross-network functional team to bring about the network of the future. I'll read a couple of them in case you can't see the screens. Future command posts will also be designed to operate at low electromagnetic signatures. The RDAS does that. RDAS is rapidly deployable distributed antenna system. The soldiers will be able to leverage commercial cellular networks along with commercial wavelengths to communicate. This system has the ability to, and is demonstrating in the SCIF that I mentioned before, integrating cellular, Wi-Fi. We have the ability to go all the way up to 40 gigahertz. So if it's UHF, VHF, all of it over a common infrastructure. And then incorporate smaller, lighter, easier to use communication technologies. You're going to see that demonstrated today. And of course, I didn't start my stopwatch, but we're about, perfect, 3.5 minutes in. It takes about 7 minutes to bring everything up. I'm going to have some admin things I'll take care of in a second. But all of this, and I can even highlight within a facility like this, there's 3 distributed antenna systems in here that we've identified. There may be more. Each one is from a different carrier. You've got AT&T, Verizon, and one that we can't identify. A system like this consolidates all of that into a single fiber optic infrastructure, so the cost goes way down. We're going to talk about those advantages going on, and that would apply, in this case, to a forward operating base or a command post. This is a tremendous cost savings in a number of ways, and we'll get into that in a bit. But for now, I'm going to go heads down on the admin side, and Jerry's going to tell you a few things about the benefits of the system.
So what Mike was saying, this is a slide we pulled down from the Aberdeen website, the tactical networks, and you see that the need is right there. There are some other quotes by Major General Gallagher, who basically said the current tactical network is basically a soup sandwich. It's bolted on from all technologies. It's not ready for the future. So there is a need, there is a problem. We're solving that problem, and that the timing is perfect because they're doing that right now, actually, with the IT and the integrated tactical network. So what Mike was saying, comms is not very sexy. but it's very, crucial. It's essential. But without it, we couldn't fight a war. We couldn't do anything, even at headquarters. So, my slide is not advancing right now. Hold on. I should have another slide up, but it's not doing it right now.
I think this one's driving everything.
Okay.
If you could cut me over and put it on his computer, just take me out of the loop.
So basically, there it is. So this network does have a lot of capabilities that sets it apart from the current technology. And if you want to invest in new technology, there has to be an ROI, the return on investment. It has to have longevity of performance, the reduced cost, weight, whatever. So our particular network has certain things that, the capacity, it improves capacity of the current networks. The Army is already moving to fiber because fiber has pretty much unlimited bandwidth, so that's nothing sexy. But our technology, the secret sauce, so to speak, in this box is made by our teammate Optical Zoom out of California. It's designed and manufactured in the United States. And it provided the capacity for the last Super Bowl at the Mercedes Stadium, and all the 100,000 people there were having Wi-Fi and cellular based on this technology, these boxes we have in here. So the technology is reliable and it provides the capacity. Also, the rapid setup, one major benefit for the system is that, when your soldier is in the field, you set up a command post, you want to set it up as fast as possible. And also you want to take it down as fast as possible because you want to get out of there when you're under fire or you need to move. This simplified network with improved capabilities actually allows you to do that. So it's up within 3 minutes actually. Our system is up in 3 minutes. We're waiting for the rest of the networks that we plug in as a source that we then can distribute over the Wi-Fi antennas. So we're ahead of everybody else. We're just waiting for, like the regular Army hurry up and wait thing. But it's rapid. The reduced weight, because it's simplified, we basically have fewer components, but we also have lighter components. And what you saw here, the RF shielding, the heavy boxes, they're very expensive. They're also very heavy. But we've already been talking to a manufacturer, and we have, and I'll pass this around. This is an RF shield. This is a fabric. This is an off-the-shelf one. We're talking to these folks and make them this small. This has an AP in it, and it has like a tenth of the weight and a tenth of the cost of the current RF shielding boxes. So again, you're reducing cost, you're reducing weight. And reducing weight is very important for the soldier because they just like not carry around as much on the backpack or heavy boxes loading out of a truck. So with all these benefits that I just mentioned, you also reduce the cost because you have fewer components. Actually, our components cost less than the current components we're using in the tactical networks. But also they're very reliable, so they don't break down as much, so you don't have to do this maintenance and you buy new equipment. So the cost reductions go down dramatically. Now the scalability and the convergence is very interesting. What Mike was saying earlier, we basically have one single strand of fiber instead of multiple DAS networks, multiple Cat5 cables, coax cables. We run the entire spectrum over one single strand of fiber, which is unique. And we can do that because we have developed, and this is, well, it's not really patented because we're the only ones in the world that basically have these multiplexes where we take multiple RF signals and put them on one strand of fiber without interference, and it works. So that is very unique. Nobody else can do that today. Eventually, they look at this and probably going to steal the idea, but right now we're the only ones that can do that, put multiple RF signals on one single strand of fiber. So no more pulling like multiple cables, multiple coax, multiple fiber strands, one single strand of fiber, reduce weight, reduce cost. So the convergence, we can basically put any RF signal on this network. Unlike here where you have one for Verizon, one for T-Mobile, one for Wi-Fi, we put everything out of one antenna like this. You see the antennas are actually in the boxes. They propagate through the plastic. The soldier just basically brings it out, sets it up, plugs in the cable, is done. 3 minutes, and your command post is up and running versus the current time. But this is an antenna that we're using, and everything comes out of one antenna. SATCOM, we can put a donor antenna up on the roof, and especially in the building where you basically have to walk out of the building into the courtyard to hit the satellite. You don't have to do it anymore. You can sit in the basement, receive phone calls, make phone calls with, it's vendor agnostic, through Raya, Iridium Global Set, everything comes out of one antenna. All the wireless carriers, Verizon, Vodafone, Docom, doesn't matter where you are in the world, We put it on this system, comes out of one antenna. All your radios you have in your field or in your warehouses, this can also go in a warehouse. You basically use one antenna, tremendous cost savings, tremendous simplicity, and it's all due to the multiplexes that we have developed and designed. So, and then simplified training, of course, simpler systems, rapid setup. The training will be simplified. It's future-proof. It's fiber. You pretty much have unlimited bandwidth. That means if new technologies come down the pike, we're ready for it. Everybody talks about 5G. 5G, the frequencies are higher. It can go up to 40 gigahertz. Now we're already talking about 6G, which they're working on. 6G can go up to 1 terahertz. This system, with the right multiplexes and the right transceivers, we can basically handle that. So it is future-proof. New protocols come out. They're RF. We don't care. We put it on this fiber strand and pump it out of the right antennas. Improved security. That is very interesting because what Mike was saying, this system is up and running in a SCIF, where for the very first time you can use wireless devices in a SCIF. Laptops, cell phones, they're government-issued devices. You can't bring in your own, okay? You still need to leave them outside, and you can't take out the government-issued devices. But now you basically can walk up, with your laptop, TSCI, JWIX, a zipper, nipper, doesn't matter, whatever network you have, walk into the conference room, keep working on your laptop, and walk back to your desk. And that is unheard of. So you can also use a cell phone. What they're doing in this SCIF, this is actually a multi-story building SCIF, and it's not just in a room without windows. It has multiple antennas, multiple access points. Folks got rid of the Polycom phones, cost savings, because everybody's using the cell phone now for conference calls. That's what you do anyway. You basically put your cell phone on the table and everybody's talking to it. So Polycoms have $10,000 licensing fees per month. They got rid of them, so they're saving tremendous cost there. So people now can receive phone calls from the outside in a SCIF. Of course, there's still OPSEC, but you basically can forward your number from your regular phone to the government cell phone, and you can receive and make cell phones. Verizon, T-Mobile, doesn't matter. We're a vendor agnostic. And it's the same for the tactical SCIF of the tactical network. So the other improved security things are, we can't really talk about it. We can talk about it after the fact. We're not here in this open forum. But there are a couple of very unique systems or features that we have, is that we control the power on the antennas. For instance, Mike, and he's going to show this a little bit later, attenuate the power levels up to 1 foot accuracy. So if I basically, this thing is transmitting, and now I have a signal, and I move it 1 foot away, I don't have a signal anymore. That's one of the security features that we basically prevent the signal from leaking out of the space, especially in an open space like a tactical SCIF, where you can control the propagation of the signal. That is very important. So if you add up all these little security features that we have designed inside this box, that's the reason why, for the very first time, wireless devices are allowed in a SCIF, and they're granted under a waiver. So now we're going through the process with DISA and the other agencies to upgrade the current policies, and that's the long pole in the tent, as you can imagine, because those people are, I hope I don't offend anybody in the room here, but very slow. The technology's here. We're ready. We've done it. We're proving it. This system has been up and running for 2 years in a SCIF. No glitches. Everybody's happy. High performance. And we basically made it happen. So that's kind of like some of the major benefits. I'm going to hand it back over to Mike right now.
Thanks, Gary.
The system is up and running.
Yeah. Thanks for tap dancing for a while. As you can imagine, with a live boot up, about everything I could do wrong, I did wrong. Starting with not powering the system on. I plugged it in, turned on the UPS, didn't start the server. So that big hum of fans you heard about 4 or 5 minutes into it, that started that 7-minute clock. I also didn't have one of my admin cables plugged in. But what you saw was, despite me floundering for a bit, maybe that's a good thing, it really only took a few minutes to plug everything in and bring it up. It is about a 7.5 boot cycle, 7.5-minute boot cycle, if you know what you're doing. And normally I do, but I won't admit it's a little bit nerve-wracking to be up here in front of you, fine people. But if we could now go over to the other display. It's not.
While Mike is doing it, I want to show you a couple of things here. These are some of the devices that we've developed. This is a converter, a transceiver, and it basically turns RF signals into light. And then on the other side of the cable, it turns light back
Okay,
into the RF signal and then goes out to the antenna. This has a laser in it. It's very robust. It's being used by a worldwide telecom company, so there's no risk involved in the equipment that can work.
That'll work.
Very simple
Thanks.
thing. And then there are two of these in one box, one for transmitting, one for receiving, and then this basically is in a ruggedized version for in the field. But what we're working on in the near future is reducing the weight of these things, because we can get that thing even smaller and cheaper, and hopefully also do it at once. But that is our goal in the next phases of the development process, the transition process.
Okay, so thanks very much. As we step into the demo, I want to reinforce a couple of points I think Jerry made, but lighter weight communications infrastructure. I should highlight that what we're actually demonstrating today are 2 of the 9 RU you see here, rack units. This blue here, and then we have a series of RF combiners that are illuminated in here that if you took a look when you stepped up earlier, you're certainly welcome to do so again later. We're taking the RF out of the access points. We're doing some combining on that. We're running into RF over fiber multiplexers and transceivers that then send it over fiber optic to these remote transceivers. The gray box that Jerry held up a minute ago is inside, mounted inside just as a proof of concept. This Pelican case, the Pelican case has an antenna and one remote transceiver. This has only an antenna in it, so very lightweight. This weighs about 7 pounds. That one weighs about 12 pounds with a remote transceiver. Those can be made lighter, obviously, with a smaller case, and there are smaller form factor antennas we could go with. But it literally is just 2 connections. One thing that is really exciting to us is the idea of using hybrid fiber optic cable. OCC, one of our teammates, we'll be talking a little bit more about later, they fabricate tactical ruggedized fiber optic cable, weighs a fraction of what copper-based conductors do. We can run up to 48 core of fiber in a tactical fiber optic cable. This is a 300-meter spool. It weighs a fifth what copper would weigh. So imagine these 2 antennae, which these are duplex, one's dedicated send, one's dedicated receive. You could run 48 pairs of those off of a single fiber or a single cable. So it's flexible. You can add right here from the head end. If you had additional RF sources, you would patch them into this panel here. So if you had iridium, so people didn't have to go outside like Jerry was talking about, or you were using GPS for time synchronization across worldwide, you could bring that in. Radios, VSAT, etc. Again, even though we've got a huge amount of gear, and the black case, by the way, is just a stand, but everything in the green case, it's really just these 2 units that we're really focusing on. The rest is just a traditional Wi-Fi network that's taken those access points. We do work directly with HP Aruba because we're working on evolving their wireless intrusion protection system, making it a lot more agile, a lot better at detecting interference. Okay, so Jerry alluded to the 2 capabilities that this has. And one of them is the Wi-Fi and cellular and integrated RF distributed antenna system. The other one is a continuous RF monitoring. That goes beyond the scope of this presentation in this forum, but it is able to detect extremely low power RF emissions, and it has functioned as such in the deployed operational skiff that we referenced earlier, found someone who accidentally brought in a low power Bluetooth headset, things of that nature. So in terms of identifying potential threats, it's effective. What you see here is just a wiring diagram, a network diagram of what we're going to demonstrate here, and it'll only take a second to do so. The green box in the lower left is a simulated NIPRNet connection. The red box is a simulated SIPRNet connection. We're running those inside, and this is why the server is in there. This is just a series of virtual LANs, VLANs, and VMs that are running those machines, and that's what I was booting up at the beginning of this as I was kind of floundering around with my connections. Sitting on top of that I just brought into view is the RDAS itself. That's, again, those two units I mentioned and these 2 antennas that you see. To access the access points, you're actually coming not through the access points, but through these multiband antennas. These are tuned to go from about 900 megahertz up to 6 gig, so that's your cellular and your Wi-Fi band. Depending upon what antennas you had would dictate what other RF you could use. Now, I don't know that we're going to have time for you to play along with this, but what we've done here and I've put some tablets in front of the judges, is you can see that we have SSID high and SSID low on this. And this is just a free Wi-Fi analyzer application. You can see that we're at negative 78 dBm. And what I'm going to do is demonstrate. Yep, you got one there. And so you can keep watching that display, and I'm going to make some changes on the fly to the power levels.
So, what Mike is doing, one thing I want to mention really quick is that what is also very unique about this system, because now you can have Wi-Fi the devices in a skiff. If you had an analyst working in a skiff, and all of a sudden he or she needed in the wireless glucose monitor, that person could not work in a skiff anymore. But now with this system you can, because we know the frequencies of that particular device. We authorize that device to be in our space, and now people with wireless monitored medical devices, which are coming more and more, can now work in a skiff with our system.
Thank you. So I don't know if you had your eyes on the screen, but about 3 seconds after I made a change here, I rolled out about 30 dB of attenuation. And I was doing some testing in this room earlier, and basically we can roll that back from people in the back of the room being able to see these two SSIDs, the high and low, again, simulated sipper, simulated nipper. We can roll that back. The fact that this system is also using multiple input, multiple output, if you noticed on the access points, when you looked at it, we had 3 wires coming off each one. We're taking each one of those antenna ports. And so if you are not inside the MIMO cluster, this has been demonstrated with our parent organization, you can't receive enough signals to demodulate that. So it's another layer of physical security. If you are outside this cluster, and on the back of these boxes, we've got a schematic to help soldiers understand that this is the operational area. You want these guys opposed 90 degrees, and whether you just threw it over the back of a vehicle, over a limb of a tree, or had a tripod or another mast of another antenna system, you could put these antennas up and array them out according to this schematic. Very simple, again, 90 degrees. And I mentioned they're duplexed antennas. Part of the reason they're duplex has to do with RF circulator and the fact that for these frequencies no circulator existed. But another benefit it has is it's fundamental in the system's ability to detect known from unknown signals. So much of what we're doing here is correlating, and I had these IPs and passwords in case people wanted to log in, but I'm afraid we've kind of run out of time. A fully evolved system, back to that second capability of RF threat detection, a fully evolved system would have software like this running in front of it. This is a mock-up of a user interface. We're in the process. We've actually have a draft patent application for the underlying software that we've designed for this, but we're calling this SIG exciser. It excises signals from the spectrum. It excises anomalous signals specifically. And so if anyone who's looked at network data might appreciate, you've basically got Wireshark on the right-hand side of the screen. That's packet-level analysis of information coming through. And we're correlating that with the client list of a server, or MAC addresses, IPs, things that can be spoofed, we know that. But then in the lower right-hand corner and in the center bottom of the screen, we're correlating those analog and digital signatures to find where there may be something that doesn't belong. Where do we have an authenticated user? What does their signal spectrum look like, and vice versa. So those are things that we see happening in a fully evolved system. I want to briefly touch on the team itself. There are a number of companies we've leaned on to get as far as we have. We bring the operational perspective to this. Prior military, used to have to lug equipment around, didn't like to have real heavy stuff, had enough of it. But we're also fairly technical. I'm computer science and math after I got out of the 82nd Airborne Division, so over the last 18 years, I've been applying these kinds of operational experiences to how can we make systems better. Sayers, a wealth of experience in program and project management, really. They're also the PM on the Cooperative Research Development Agreement, so they have provided us direct access to the government sponsor, and we've seen how this system works inside a SCIF. And then Optical Zonu and OCC, they're the hardware manufacturers, all US-based manufacturing. They make these blue boxes here and the cable that I showed you earlier today. Phenomenal companies, and Aruba as well has been working with us on the DAS configuration. As Jerry said, these systems it's viable. I mean, these systems are in use. The commercial carriers are buying them in volumes. Building owners like this would want to buy a system like this. I know we're not focused on commercial, but you know, you're not beholden to a given carrier. You can switch your carrier at will because you're pushing whatever signal you want through the infrastructure. Already started to talk a little bit about viability. We've we've been gradually building this concept out since the initial white paper in response to the Phase 1 X-Tech. We also submitted that paper with some minor tweaking to the SBIR Phase 1, which we found out just a couple weeks ago. We've got a Phase 1 award pending. We're grateful for that, of course, and that gives us another milestone. It's actually a 6-month feasibility assessment we're going to do to really work with probably the guys at APG to see how this would fit into their CON-op. And then I would just point out that beyond the experience of those larger companies that we have built under different hats for different companies, built systems from R&D all the way through transition and acceptance to programs of record. So we're working we're in a comfortable space in terms of maturing technologies. We think we're pulling some valuable lessons learned from the past to make this thing a reality. A final point that relates to the overall impact this would have on the Army. The core technology, some of the things that Jerry was passing around earlier, this can replace coax for satellite terminals where you've got limited standoff distances from a dish. You can go right to the LMB of a satellite dish and switch from copper or coax to fiber, run at 50 kilometers if you want. It's a phenomenal degree of flexibility, and then the convergence, the ability to run all these things over a common infrastructure. It's going to save a huge amount of money for transportation because you're not moving as much stuff. It's easier, fewer parts really. You're not worried about the physical connections. I mean, I know that in Afghanistan it was a constant battle with the dust. You've got Cypernet jacks and the RJ45, the plugs. Nothing works very long in the dirt. If you can go wireless, you don't have a physical connection, or you have fewer physical connections. And I know we're just about to wrap up, but I encourage you to look at these ruggedized these connectors that we've got, both for hybrid, where we can run power and data over the same. In fact, we've got a small snippet of that. I'll pass this along. This is what the hybrid fiber looks like, and that's got conductors we can push out to a few hundred meters so we can actually power devices without local AC or DC power. We can run it right over the same cable, as well as along with 8 or 6 additional fiber optic cores. So you could have, through that cable, power to all these devices and a total of 6 pairs of these antennas. In closing, we'll talk a little bit about transition. Obviously, the SBIR Phase 1 is fundamental. We're continuing to explore relationships with C3 Tactical. We think that and I've got some past experience with the teams at Aberdeen. I think that that's going to be a hub of the requirements capture and analysis process to make sure we refine this to what the soldier really needs. And then we're pursuing a number of relationships through the small business offices. We have meetings throughout this week. One of which is with DISA, as Jerry said. Under the CRADA, we're going to be helping revise what the policies and regulations are as they pertain to wireless security, wireless networks. And then in terms of the risk management, we're continuing to nurse relationships, not just with the U.S. Marine Corps looking for SOCOM, but that we've also had discussions with NGA and how they might fold this type of capability into their operations, as well as within their new facility they're building in St. Louis. So there's a huge amount of traction we're gaining here. We think that we've got the right team to do it, and it's definitely something that the warfighter needs. I can say as a former soldier, definitely would have liked to have lighter weight comms. So I think that's everything.
Yeah, one last thing I'd like to mention, what we haven't really touched on, we also have a system built into this network. It's called OTDR, which is a fiber fault detection system. So within a 100-kilometer cable, we can instantly detect where the break is within 3 meters. So instead of trying to figure out where it is, you can easily tell it's over there, so fix it. And with that, there's another Delta Power systems where you basically can you wiggle the wire, and the power in the wire basically in the fiber changes, and we can tell if somebody's doing that. It could be a squirrel chewing the cable, or it could be a truck, but we can set the sensitivity. So this will basically prevent adversaries from tapping the cable, because they immediately know, hey, somebody's screwing around with our cable.
Thanks, Jerry. You also cued my memory on the 2 devices that I'm passing along. I want to point out these are hot swappable. We talk about flexibility. These transceivers, the multiplexers in this blue chassis, are hot swappable. So if someone shows up with Inmarsat and they need to plug into the network and distribute that, you just switch out one block on the chassis. The smaller unit these passing around, anyone who's worked in network infrastructure, we'll notice that's a small form factor transceiver, pluggable transceiver, SFP, standard form factor. The carriers are buying that exact model by the thousands every year from Optical Zone to the manufacturer. They've got a patent on that with the micro OTDR. For those that aren't familiar with OTDR, optical time domain reflectometry, it's how you detect a fault in fiber optic cable. Normally you have something go wrong. Thank you. Did you guys have a chance to see that? Let me bring it over. Normally if there's a fault in the fiber, you will bring a technician out, the network's down, they plug in some additional test equipment, they can identify, okay, 475 meters down this particular fiber path, you have a break. This has patented, encrypted firmware running on it that does that instantaneously. In fact, in our booth on Wednesday, we're going to be showing a live demonstration of that with about 25 kilometers of fiber on spools showing you where breaks are instantly recognized. So that then, depending upon what environment you are, that might be a text message to your admin to say, hey, right here on your network map is where there's a break, whether it's a backhoe went through it or a tank rolled over it. So that instantaneous recognition of a fault, as well as what Jerry was saying, Delta Power Sense, is phenomenal in your ability to detect tampering as well as intrusion or breaks in the network fiber, all baked into the system. Thank you very much.
Thank you.
Any questions? Or was that it?
That was it.
That was the whole time.
The whole time.
Shoot, sorry about that.